Hello everyone, and in this video I'm going to show you how to solve a 3D stress problem using Abaqus. As you can see here, this is from tutorial 5 for Abaqus simulation here. So this is very similar to the tutorial 3 where you uh, use the plane stress element to analyze the plate with the hole and with pressure on both ends there. So we can analyze that actually because the thickness is very small compared to the other two dimensions. We should be able to use plane stress to analyze it. But here today we are going to create the model for the as a three-dimensional model, and we create the thickness and for the plate too. So we, instead of using plane stress elements, we use 3D stress elements over here. So we create a three-dimensional model over here. Please keep in mind that we use the same dimension, the 4" by 2" by 0.1 inch. We have the modulus of elasticity and the Poisson's ratio. I have 100 psi over here, let's say, and what would be the difference between the analysis using plane stress elements and the 3D stress elements over here. The first thing we create the model in Abaqus geometry. So you open the Abaqus. I'm going to change the work directory here to my favorite. Uh, oh, sorry, favorite plate, favorite place. So that's online course. We create a new folder, tutorial 5. So everything will be stored over there. So later on, if I would like to check my results, I can re and open the files over there. So now let's create the model. So in the tutorial, we sketches are used. So we just create a sketch. Program may says we have 4" by 2" by 1 by 0.1 inch beneath. Yeah, so we have the whole size is 1 inch. So we can have the approximate size would be 5. So now we create a sketch here. So we just create the 1/4 size over here. We create that. So this would be 2 by 1. So 2. So 1, 2. This is going to be 2 by 1. And then we go make the hole. So there is a hole here. Center. Start point. That's one hole. The diameter. So we have 0.5. 0.5. 1. Oh, no, something wrong here. We create a arch. Center is here. Start point. 0.5. 0. And here. So that's the hole up there. And then we trim to the trim. So we have already created the sketch here. So we are done. So we have one sketch over here down here. Now we go to the parts. We would like to create the real 3-dimensional geometry. We create a part, the 3D, deformable, and that's a solid. So we will do the extrusion through the thickness. So we just upload the sketch. We have the sketch, and we are okay with the position here. So now we need the extrusion. The extrusion. Okay. So the depth will be 0.1 inches. So now we have the model. So 0.1 inch thickness and 1 inch here and 2 inch here. We have everything's ready. Everything's ready. So we save the model. This is the model that we're gonna use. Then we create the material properties. This is oh, sorry, I forgot about that. So the tens 6 order psi Poisson's ratio, that's 0.3. Have it over here. Then we create a section using the material we defined a few seconds ago. It's solid. Click OK. So that's material 1. Okay. And then we assign that section to that material, that region. So we're done for this step. Properties are done. And we may go apply the XY view so that we have a better control of the geometry because we don't worry about the thickness in the other direction. So we go to assembly, create an independent mesh on instance only. And then we go to step, we create a static analysis step. We are done. Then we go to load. So the load is important. So we have symmetry here and the symmetry here, and we just need pressure over there. So now we apply the boundary conditions firstly. Symmetry, but that's Y symmetry here. Continue. We need to select the bottom. So that means we need to rotate that a little bit. So we do a little rotation here. And select this region. So that's the Y symmetry, and then move here is equal to 0. Is equal to 0 over there. Click OK. Then we apply symmetry above the x-axis here. So we back to x. Then we do a rotation. We would like to select this side. Symmetry. This is the x symmetry. So we have the x, the y symmetry. Everything is applied. Next step, we need the pressure. We need to select the top edge. So I do a rotate here. And apply the pressure here. So that's 100 psi. Then I remember 100 psi, but in different. So minus. So when you talk about pressure, we talk about the. Yeah. So let's see the boundary conditions. We're done. Okay. So next step, we go to mesh. And now let's say what mesh the tutorial requires us to use. we are required to do element size 0.1, so entire material. So we try linear or quadratic position both ways, and then we just apply the pressure. So we use different shapes over here. Yeah. So now let's say let's use a unit size 0.1. So we just select the global size. The global size is 0.1. Assigned. Then we like to use the standard. We use tetrahedral linear combination firstly. So that would be followed. We are down. And then when we go to mesh, do the mesh control, we like to use that there is no sweep or free. You can try sweep firstly. Tensor free. We try free. And so when do the mesh, the mesh is done. As you can see, if you rotate it, you will see the mesh is also done. The extractions, the thickness direction. So this is the mesh we have over here. The reason why I just use the 1/4 just because I would like to reduce the total number of elements and here. So we go to job, model, and then we go to job. Then we created a job. We do the analysis and submit the work. Yeah, it's completed. So we should be able to check the stresses. We would like to check the stresses. For example, the family says stresses, or we check the SS22 because that's the stress in the y direction. That way we can uncheck the average over here and to show the stresses in separate elements here. As you can see here, there are some so the maximum stress is 3.3 something. The 331 psi somewhere over here. So this is we can rotate it a little bit and to show the stress in this direction. Yeah. So that's how we, I would say, creating using 3D elements. Creating is very straightforward. The only issue is anytime when you use 3D element, you would like to you better consider reducing the overall size of this problem, such as considering the symmetries and to have a smaller number of loads and elements, or so that you can run it in a much shorter time. The second challenge is how to mesh it, because sometimes when you have a very complex geometry, you better come up with an idea how to have the meshes, such as anywhere you have stress concentration, you would better to use this finer meshes. So somewhere you'd better to use finer meshes over there. So that's what we have over here. Looks like my result is a little bit different from the we're showing here, but let's see, maybe because my boundary conditions here is there is not so strict as shown over there, but you can try following the same boundary conditions shown in the tutorial to find out the maximum stresses there. So I think that's all we have for this video. Good luck to your simulation, and I think that's all. Thanks.